Okay, in this pre-cal video, we are still in Unit 7, and we are going to explore simplifying our expressions by rewriting them as a single term. Now, what I mean by that is that we are going to manipulate these expressions mathematically, and we are going to use values off of our identities page to rewrite things to basically transform them into one term without any addition and subtraction. So we're eliminating addition and subtraction in our final single term and no fractions, okay? So those are the things that we are hoping to accomplish here. So let's look at number 10. We have cosecant theta, secant theta, and cotangent theta. So we don't have any fractions, so we don't have to worry about combining those in an awkward way using our lowest common denominator or anything like that. But we do need to change these into workable values. So right now I've got three different things going on: cosecant, secant, and cotangent. But each of these things can be written in terms of sine or cosine. So let's look at our identities page, and we can figure out how to reframe these expressions. So cosecant can be written as sine over theta, secant can be written as 1 over cosine theta, and cotangent can be written as cosine over sine. We wouldn't want to use this value for cotangent because 1 over tangent doesn't get us anywhere helpful. So I am going to rewrite these things using the reciprocal identities . And so I get this right here. Oh, why did I write? Out of control. Okay, and I wrote that wrong. It can't take me anywhere. Sorry about that. Okay, so what we have here now is we've got these two fractions multiplied together, so I am just going to write those as one fraction. And then we're subtracting another fraction from it. So what we want to do here is we want to get a common denominator so that we can combine these fractions into one term. So we are going to find our LCD. Our LCD has to consist of everything in this denominator and everything in this denominator. So we have to have a sine theta and we have to have a cosine theta. So the value in this denominator that's missing is cosine. So I'm going to multiply the numerator and the denominator by cosine theta, because I can multiply anything I want by any form of 1 and it won't change the value. It might change what it looks like, but it won't change the value. So this denominator is set already over here. So I've got 1 minus, these two get multiplied together, so that's going to be cosine squared theta over my denominator. And now we're down into one fraction, so that's good, but there's not really anything we can do from here. So I'm going to revisit my identities sheet, and I'm going to look at my Pythagorean identities. And there is one right here that I can use, 1 minus cosine squared theta. I can replace that with sine squared theta. So we are going to do that. And then what I end up with a way to reduce this. So now I've got sine theta over cosine theta, which I can actually use another identity right there, my tangent theta. And look at that. Nice and tidy, one term, no fractions, no addition and subtraction. Beautiful. Okay, let's look at the next one. So with this one, what we want to do is let's rewrite it so that it's easier to work with. We're going to write it old school division. Oh, these are x's, not thetas. All right, so like I said on number 10, when in doubt, let's try to change things into sine and cosine terms. So tangent, I'm going to change to sine x over cosine x. That's one of our quotient identities. Plus, I'm just going to leave sine x here, but I'm going to put it over 1 so that I'm using some consistency. And then secant x, I am going to change that. Okay, I know that secant x equals 1 over cosine theta. Divided by, I'm going to change cosecant to 1 over sine. And I'm going to change tangent to sine x over cosine x. And you'll see why I'm doing this. So the first thing I want to do, I've got sine x over cosine x, plus I'm going to multiply these together. It's easy peasy. Sine x times 1 is sine x. 1 times cosine x is cosine x. Divided by, and I can reduce these here, so I end up with 1 over cosine x. And then these two fractions have the same denominator already. So I've got sine x and sine x, so that's 2 sine x over cosine x. And then since I have division here, I'm going to multiply by the reciprocal of this. So I get to reduce, and I end up with 2 sine x. Beautiful.